Sir, can you turn on slideshow? Okay. Okay, shall we start?
Yeah, sure.
Okay.
Is it audible?
Yes, ma'am. Sir, 1 minute. Okay, we can start. Some participants are joining. It is audible, sir.
And visible also?
Yes, visible, sir. Welcome back to day 6 of our online FDP. Coordinated by Department of Electronics and Communication Engineering of Jyoti Engineering College, Tirupati. Let me introduce our resource person for today, Dr. P.T. Matthew, sir. Dr. P.T. Matthew is a senior officer of the Indian Telecommunication Service who served as Senior Deputy Director General, Kerala Licensed Service Area under the Department of Telecommunication, Government of India, a role that placed him at the helm of telecom regulation, policy, and infrastructure oversight for Kerala. With decades of hands-on experience in the governance and deployment of national telecommunication networks, he offers an invaluable policy and implementation perspective on the evolution from current networks to 5G and beyond. He currently serves as adjunct professor in the Department of ECE at Jyoti Engineering College, Thrissur, actively contributing to the academic development of future communication engineers. We are honored to invite Dr. P.T. Matthews to deliver an online session on next generation communication network, 5G, 6G, and the future, at our faculty development program on advanced communication systems, shaping next generation networks, organized by Department of ECE. We warmly welcome your gracious online presence and valuable insights to our faculty community. Welcome, sir. Welcome to the FDP.
Very good morning to all of you. Thank you for the welcome address. And I'm very happy and privileged to be present here, the auspicious occasion of this FDP program. I think today is the last day. I was associated with the development of telecommunication services during the last 4 decades in India in various capacities at these various locations. Also today, the telecom infrastructure in India is one of the best in the world, we can say. The telecom tariff is the lowest in the world. An average Indian mobile user consumes over 31 GB of data per month, establishing India as a global leader in per user data consumption. The digital ecosystem is supported by an active internet user base of approximately 958 million people, capturing an overall internet penetration of roughly 70%. So today we are going to trace one of the most consequential engineering stories of the last 40 years. The evolution of mobile communication from the first analog phone calls of 1G all the way to the artificial intelligence native network of 6G, which is going to be implemented by 2030. So here is a roadmap for the session. So I just cover from 1G to 5G. That is a historical development, why it happened, how it happened. Then the 4G and broadband revolution, the 5G technologies and its applications, 6G vision and the future network, which is yet to be developed and commercially implemented. The emerging technologies, semantic communication, ISAC and quantum networks, and the career opportunities, especially in this field. So we'll start with the historical arc from 1G to 5G, then go deeper on the 4G broadband revolution and the 5G technologies that are reshaping industry today. From there, we look forward to the 6G vision, survey the emerging technologies, semantic communication, integrated sensing, quantum networks, and finish with the career opportunities, all of this opening up for EC graduates. So feel free to hold your questions for the discussion. We'll have a discussion at the end, question answer session. So before the technology, let us anchor the scale. There are more than 5 billion mobile users on the planet. Connectivity is now as fundamental as electricity or roads. The telecom infrastructure in India has changed the scene throughout. There are ideas to keep in mind. First, communication is the backbone of the digital economy. The finance, when you look at finance, healthcare, smart cities, all rides on it. Suppose you are doing a banking transaction today, because the verification is done through OTP. And without a very strong communication network, this is not possible. Second, the modern systems are multimodal, voice, video, data, and machine to machine traffic all at once. And the third, the pace of change is driven by convergence. That is artificial intelligence, the cloud computing, edge, and IoT pulling together. So evolution of mobile communication, when we look at it, the next slide, there is a 1G to 6G. Started from the during the year 1980, that it started with analog voice, the first generation. The technology which was used was FDMA and AMPS, and it was only an voice only communication. And each the single slide is a spine of the whole talk. Roughly every decade since the 1980s, a new generation has arrived, and each one delivered an order of magnitude jump in capability. First, he gave us analog voice alone, and when you look at it, the 2G, that is, it is somewhat digital. It's made it, it's subtexting, like SMS is added. 3G brought the mobile internet, and the technology is WCDMA and HSPA, and the speed is approximately 2 Mbps plus. And the 4G delivered a true broadband, and in India also. In fact, with the introduction of 4G by Reliance Jio in the year 2016 on September 5, the revolution of telecommunications started. In fact, the usage of internet has exploded with the introduction of 4G, a total IP network by Reliance Jio. And they have not started with 1G or 2G or even 3G, but they started straight away with the 4G. And subsequently, they have started 5G. And the 5G connected machines has massive scale, and 6G is in the testing stage by various countries. In our country also, some of the IITs are also developing the technology. And it is expected that by 2030, it will be commercially implemented throughout the world. And we will also enjoy the fruit of 6G. It is aims for an artificial intelligence native operation at terahertz frequencies. Notice the pattern. It is not just the faster. Each generation changes what the network is for. So when you look at the first generation, let us start the beginning of 1G. In the 1980s was purely analog and purely voice. No texting, no data. It used frequency division multiple access. So each call occupied its own slice of spectrum. The dominant standards were AMPS in North America and MT in Scandinavia. The limitations were severe by today's standards. So very poor spectral efficiency, no encryption by which anyone with a scanner could listen it. And bulky, the handsets were very bulky. And almost there was no roaming, but it provided the concept of people. So you can reach at any time wherever you are. That was the major advantage. When you look at the second generation, 2G in the 1990, after 10 years it was introduced commercially, was the leap to digital. And it is arguably the most important transition on this whole story. Going digital meant we could compress, encrypt, and add services. TDMA and CDMA replaced analog FDMA, and GSM became the global standard. It's in fact started from Europe, and that is the standard which we also adopted. This is when SMS arrived and almost as an afterthought, and then it exploded. We got basic data with GPRS and Edge. Critically, the SIM card brought authentication and encryption, fixing 1G security holes, and GSM standardization enabled roaming across 200 plus countries. So anywhere in the world, we could roam. That was a major advantage of. Where we transmit, meaning rather than raw bits. When you look at 3G communication, so the technology which is used is WCDMA or UMTS enabled, and it's an IP connectivity. Peak data rates of 2 Mbps it started with, and HSPA Plus could give a 42 Mbps data. And multimedia services were also available. The video calling, mobile TV, streaming, audio and video became commercially viable for the first time. Mobile web and GPS enabled practical mobile web browsing, integration of location services, because which we all are using the GPS services nowadays, where whenever you are going by a car, you'll always use the GPS services. And the social media revolution, 3G infrastructure, in fact, the Twitter, Facebook, mobile, and the app communication, everything is developed by this. In fact, when you come to the 4G LTE, the broadband revolution. So excuse me, because are you able to hear, or because all these topics were recently covered, because I was not associated with this. Is it covered? Hello? Neetu? Hello? Are you able to hear me?
Yes, sir.
Yeah, because these topics were covered earlier, because I just want to know, because in fact, because it should not be a repetition for you. Any response?
Yes, sir.
Covered, huh?
No. These are not covered, sir.
Okay. So 4G, because the in fact long-term evolution, that's the technology which is used, and the downlink means the practical speed is around 100 Mbps, but theoretically it is expected that 1 Gbps maximum speed can be given. And the latency, because it's reduced considerably, that is less than 10 milliseconds. That's the beauty of this system. And the technology, the orthogonal frequency division multiple access technology was used, and it's a totally an IP infrastructure. And when you look at the core, that is evolved packet core, that is earlier the circuit switched elements were replaced by evolved packet core switching, and seamless handoff between long-time evolution and Wi-Fi. It was also possible. And for the voice, because voice over LTE, earlier the circuit switched voice system was used in the earlier systems. Here, voice over LTE is introduced, by which a very good audio quality and simultaneous voice data usage without fallback to 3G. And in this technology, not only the human to human communication, in fact, machine to machine communication is introduced. LTE-M and narrowband IoT extensions enabled low power wide area IoT connectivity, a precursor to 5G massive IoT. So when you look at the 5G intelligent hyper-connected network, from 2020 onward, it's best understood not as one thing, but as three service classes. This framework is worth memorizing. That is EMB, Enhanced Mobile Broadband. It's a fast pipe, a maximum speed of up to 10 Gbps. Earlier in 4G, it was only up to 1 Gbps. 4K streaming is possible. AR, VR technologies are also introduced here. The next major feature is ultra reliable low latency. The latency was approximately 10 milliseconds in 4G and it is reduced to almost 1 millisecond here. And a massive machine to machine type communication. It support a million devices per square kilometer. In a square kilometer, the machines can communicate more than 1 million, 10 lakhs machines can communicate, by which the smart cities could exist. And in addition to that, our homes also, we can make smart homes. And underneath, say, nebulous, wave, massive MIMO, network slicing, edge computing, and beamforming. Hold on to these three classes, they explain almost every 5G use cases. In fact, 6G vision. In fact, it is a vision because the technology is under development. That is the future. Now we look forward to 6G, targeted for around 2030, with a headline peak rate near 1 terabit per second. The expected data speed is around 1 terabit per second. For ideas, define it. It is an artificial intelligence native. Intelligence is built into the network core itself. It's not bolted on like 5G. It uses terahertz spectrum to reach those terabits per second rates. It introduces integrated sensing and communication where base stations also act as radar, and semantic communication where we transmit meaning rather than raw bits. We normally in the semantic communication is a communication paradigm in which nowadays in fact the zeros and ones we are communicating by bits. But here it's a communication paradigm in which the goal is to transmit the meaning, that is the semantics of a message, rather than the exact sequence of bits or symbols. We'll unpack each of these later, but the theme is clear. 6G plus the line between communicating, sensing, and computing. So here you can see that the integrated sensing, that is the base station simultaneously communicate and perform radar sensing, enabling environmental mapping also. What is happening in the environment, it can map and accordingly it can communicate. And the speed is almost terahertz. The spectrum which is being used is also in the terahertz spectrum. 0.1 to 10 terahertz enables terabits per second scale data rates, demands novel antenna design. Again, the antennas also. Here we are using the multiple input, multiple output antennas in 5G systems. Here, the antenna also has to be, the design also has to be enhanced to transmit such a large bandwidth and speed. And the semantic communication, that is a transmit meaning rather than raw bits. Artificial intelligence driven compression and dramatically reduces bandwidth requirements will be reduced considerably. So now we'll compare, that is a 1G to 3G, but each this comparison, we can see that it is stable. It consolidates the first three generations side by side. In the first generation, analog FDMA, the technology, second generation, digital TDMA or CDMA, and third generation, the packet switch WCDMA technology wise. As far as the service is concerned, the first generation voice only, the second generation voice, SMS, and GPRS. And the services which in the third generation is web, video, and location. And the speed wise, when you look at the first generation, speed was only around 2.4 kbps, very low speed. And 2G it is around 384 kbps. And in 3G, it's a 42 Mbps. That's the technology. High-speed packet access plus technology, when it is being used, the speed is also enhanced. And as far as security is concerned, in the first generation, there is no security. And the second generation, the SIM authentication is introduced. And the third generation, the mutual authentication is also possible. So in fact, the standards, various standards are adopted. AMS NMT, first generation. Second generation, GSM. The European countries, they introduced GSM technology. In fact, US and China, they went for CDMA. And the third generation, it is a technology is UMTS and CDMA 2000. In fact, when the 4G LTE, now we zoom in 4G LTE because it is the foundation, everything modern sits on. The defining decision was going fully on all IP. 4G eliminated the circuit switching totally. And every service, voice, data, video, runs over this IP network through evolved packet core. Long-time evolution, advanced added carrier aggregation to chase that 1 gigabit peak. Latency dropped under 10 milliseconds, enabling cloud gaming and live streaming. And think about what 4G actually unlocked economically. Ride hailing, mobile payments, OTT platforms, remote work, the entire app connectivity runs on 4G. In fact, during the COVID-19 period, most of us were working online. In our time before that, we were always thinking that the employees, when they are sitting at home, the output will be always less. So we always force them to come to the office. It is proved in the other way. During COVID-19, work from home is introduced, and most of the organizations are still continuing it. And in fact, the efficiency of the employees also is not compromised. And for the employee as well as for the employer, means the office space is not at all required. And so with the minimum space they can manage. I could see some of the offices. In fact, recently I visited Singapore. I could see some of the offices in which one employee will come to a particular room on Monday. The next employee also use it. They will all share that office space. And as far as the cost, like the capital expenditure and the operational expenditure is concerned, the organization is saving a lot. And employee is also very happy. He's able to work from home and according to his convenience. And in fact, without compromising on the quality or output, he's able to produce. And as far as the education field also is concerned, the students were not provided mobile telephones earlier. During that time, we have all equipped the students with the mobile instrument and through video conferencing, the classes were taken. In fact, because that was also made possible. And again, the online shopping was also flourishing and digital payments. In fact, during that time, the digital payments were also introduced and India is having the maximum UPI payments happening in a day. And during the last year itself, in fact, we have overtaken other countries with respect to UPI online payments. When you see the 4G LTE architecture, the user equipment, that's the mobile, smartphones, tablets, or IoT devices, that is we are connected by LTE. That is through the radio network, it's connected to the BTS. We normally see a tower that is called the base transceiver station. So these smartphones, tablets, or IoT devices will connect to that BTS. And again, the radio access network. This is a LTE base stations. That is the E0Bs, and the technology is OFDMA and SCFDMA, and for the uplink and multiple antennas. In fact, 64 to 256 antennas are used for multiple input, multiple output to increase the spectrum efficiency. And then it is connected to the core. In fact, when you look at it, because in Kerala, very few number of cores are only, because if you look at a 4G network of Reliance Jio, they have got a core in Cochin and another standby and different location. So then all these are connected through optical fiber network or through mobile network to this particular core. And this is called Evolved Packet Core, EPC. And here the various activities are happening. It handles the mobility or the authentication of the customer and the routing of the calls. And again, IP multimedia is the different type of voice over LTE, because nowadays the voice is almost free. It is provided. Earlier it was, when the mobile was introduced, during that time, a 1 minute call was approximately costing around 16 rupees. Now it is given as a free of cost. It is an add-on. and VoLTE RCS video calling, and IMS delivers IP-based multimedia services. Here is a 4G LTE architecture. It's in the 4 layers. Because 5G is refinement of this name chip. At the edge, user equipment, they connect to the UTRAN, the radio access network of eNodeBs using OFDMA and MIMO. Behind that is the evolved packet core, the MME, serving and packet gateway and PCRF. Handling PCRF is a policy and charging rules because depending on the customer's plans, the charging is to be decided. And a customer is having sufficient balance, that is, and he has to be authenticated and the call is to be routed. Suppose a person is calling from Shornot to Delhi because the call is to be routed accordingly. And the IP multimedia subsystem, the delivery, voice over LTE and video. The key technologies listed in the bottom, OFDMA, MIMO, carrier aggregation, and VoLTE are the vocabulary you will keep using through 5G. What are the major applications of 4G? This is where the theory becomes everyday life. Sustained 20 plus Mbps made HD video streaming mainstream. For example, Netflix, you're all enjoying the fruits of Netflix, YouTube, live sport, and the FIFA World Cup, which is happening, and we are all able to watch with full 100% efficiency. Cloud apps and enterprise software as a service became usable on the move. Online education, because that is every day it's happening. The live lectures and remote labs reached students on phone. Video conferencing on mobile became viable, which we all relied on heavily. Mobile gaming and digital payments. UPI, the contactless scale to billions. 4G didn't just make things faster, it created entirely new industries. In fact, according to UAE, 144 crore Aadhaar is available in India. And this is the world's largest biometric ID system. These are all running on because of the 4G and 5G telecom systems. And as far as the UPI payments are concerned, online payments, 241 billion UPI transactions happened in the year 2025-26. And again, it is the world's largest UPI system, which is in our country. And so when you compare the communication system of our country with other developed countries like China, Japan, and all that, can say that we are almost comparable, or even in some areas, it is much more advanced. So what are the major advantages of 4G LTE? The advantage of 4G, summarized by the numbers, around 150 Mbps is a practical data speed downlink, and 50 Mbps downlink is a practical data speed, and the latency under 10 millisecond. VoLTE gave CD quality voice with no more drop calls during data use. Pages load in under 2 seconds. Video is smooth at 1080 cells and handover between cells in seamless sub 10 millisecond latency open real-time interaction. Gaming, augmented reality, remote desktop, everything is possible. And it holds full broadband even at vehicular speeds up to 120 km per hour, thanks to the Doppler compensation. The Doppler compensation is the process of adjusting transmitted or received signals to correct for the frequency shifts caused by a device movement. In short, 4G made broadband genuinely mobile. So introduction to 5G. Here we are getting an ultra high data speed. The peak theoretical data speed is a 10 to 20 Gbps because it's all depending on the number of customers in a BTS, and the practical speed that is around 100 to 900 Mbps, we can say. It is around 100 times faster than 4G LTE. So the latency, that is when we are transmitting the data from one point to another point, because during that time, the latency matters a lot. Ultra latency is required, in fact, in the autonomous vehicles or remote surgery. Earlier, I used to hear that because most of our politicians, they used to travel to US for carrying out any type of treatment or surgeries. But nowadays, it is possible a doctor sitting in New York can conduct a surgery for a patient who is admitted in a hospital in Trichy or Shannur. In fact, the robotic arms will be controlled by a doctor sitting in New York by using, in fact, the media in which the transmission is taking place through 5G network. The massive device connectivity, that is the next major important factor. So more than 1 million connected devices nowadays, because most of the activity, the sensors are utilized for various purposes. The backbone of smart cities. The smart city, we can monitor the traffic you can monitor online, and accordingly you can control or divert the traffic so that because the traffic will be uniformly distributed within the city. In agriculture fields, in fact, sensors can be introduced in the soil, and these sensors will measure the moisture content of the soil. And when it goes down below a particular optimum level of moisture content level, the pumps can be started. Otherwise, because we are simply watering the plant, it may not be good for it, as well as the energy consumption is also becoming very high. And the AI-enabled network management, that is 5G NR use machine learning for predictive resource allocation, self-optimizing network, and intelligent spectrum sharing is also possible. So when you look at the network architecture, it works alongside the existing 4G because most of the telecom operators are using 4G and 5G in other countries also. The 4G network, for example, in a BTS, the 4G equipment is there, and along with that 5G also will be there. Doesn't replace it overnight. A mobile network has two main parts. The radio access network, that is from the BTS, from the tower to the consumer, and the radio access network and the core. On the radio side, 5G uses macro cells with massive MIMO at sub 6, the frequency band below 6 gigahertz for wide coverage, plus dense small cells at millimeter wave frequencies for high capacity over short distances. Placed every few hundred meters where demand is high, because where in the cities we have to install small towers, so around 100 to 200 meter distance. But in the rural areas where the requirement is less, it may be within a 1 kilometer, 2 kilometer distance, we'll be installing the towers. The 5G core is designed as a cloud native service-based architecture with distributed local servers at the edge. These local servers cut latency and enable network slicing. For example, there are different services running from a BTS. For example, in a city, for an area, for an emergency service running by using one slice, and a low latency vehicle oscillation, that will be another slice, and avoidance of handle right at the edge rather than round tripling to a distant data center. So this way, that is a 5G radio access network. That is a node beast, the macro smell, massive MIMO, and beamforming at subs means less than 6 gigahertz and millimeter waves. And the network slicing and edge, isolated virtual networks are formed so that because without any interference, different networks will have a physical network is divided into virtual networks. So what is a massive MIMO and beamforming? In fact, the spatial 64 to 256 antenna elements transmit independent data streams to multiple users simultaneously. This is meant for multiplying the spectral efficiency without extra spectrum. The spectrum is normally auctioned by Government of India and is an expensive commodity. So the telecom service providers will try to utilize the spectrum with maximum efficiency so that the capital cost can be minimum. And the beamforming, the digital and hybrid beamforming steers narrow signal beams to individual user devices, reducing the interference so it will be transmitted through a narrow beam so that the interference can be reduced to a minimum extent. And the spectral efficiency, the massive MIMO achieves 10 times higher spectral efficiency compared to the 4G network. And it is critical for dense urban deployment, especially in the urban area, because this is very critical. And in the stadiums also, because maybe the number of people watching a particular match more in lakhs, the spectral efficiency is very much required. And a 3D beamforming, a full dimensional MIMO arts elevation control alongside an azimuth, enabling the vertical sector management in high-rise buildings. So that in the high-rise buildings also, this beam forming is essential. And so narrow beams has to be directed to that particular area by which the efficient communication is possible. So the network slicing and edge computing. Network slicing and edge computing, these are the two ideas that together redefine what a network is. The slicing means we carve one physical network from there will be one physical network into different multiple logical network, each with its own guarantee. So a single 5G site can simultaneously run a consumer broadband slice, a factory ultra reliable slice for a particular factory, and a smart meter IoT slice with no interference at all. Edge computing, and then puts compute right at the base station, processing data in 1 to 5 milliseconds instead of round tripping to a distant cloud. For autonomous systems and AI, the locality is the whole game. Slicing plus edge is why 5G is called a platform, not just a pipe. In fact, recently I visited a Toyota vehicle factory in Japan. And there I could see that there is no human being. Almost all the activities are done by robotic arrangements. Because in the factory, starting from the spare parts, assembling, welding, everything is done. When I was interacting with the officers there, they were telling that earlier it was very difficult because the human hand was not able to reach certain locations in the vehicle. And now because the robotic hands, it can turn in different angles by which, because this is very easy to do. And in the other way, we are interacting with some of the surgeons here, and even in Cochin, some of the hospitals have already introduced robotic surgery, and their advertisement is also that because the surgery is not done by human being, the doctors, but it is actually the hands of robots are utilized for carrying out the surgery, and they are also telling that when the insertions are possible with a very small hole, and again it can reach the exact location by a robotic hand. Network slicing and edge computing that together redefine with a network. So when you look at the applications of 5G, 6 concrete examples. One is the smart cities. In fact, in India, more than 100 smart cities are there. Kochi and Trivandrum, these are also smart cities. Here, the traffic, intelligent traffic is possible, and infrastructure control and the city scale, the monitoring of various activities possible by CCTV cameras placed at various locations, and autonomous vehicles. That is, in fact, it's not practically introduced in our country, but in US, in some areas, it is introduced. And they say the accidents are comparatively minimum. The sensors, radar, and these different technologies are used, and by which almost 360-degree monitoring is there. So the accidents can be minimum. And here also, the 5G technology is being used. Remote surgery, it is practically being, because of the ultra low latency, this is possible. It's clinically viable across hundreds of kilometers. And industrial automation, wireless factory flows with the cobots replacing cabling. There is no cabling, it's through wireless. These are all connected. Augmented reality and virtual reality. Under the headset, because for the education as well as research, virtual reality is being used in a big way. In industry, the fourth industrial revolution, in fact, with the introduction of 5G, the fourth industrial revolution has happened. 5G has the backbone for digital twins and predictive maintenance. The predictive maintenance sense, because normally when an equipment breaks down during that time only the maintenance is done. Here in this technology, we can predict well in advance when that equipment may fail. Accordingly, the maintenance can be done well in advance. And another area where the raw materials, the minimum inventory is only to be kept in the factory. When the inventory reaches a minimum level, on optimum level, it can be ordered. And in a yard also, by using drones, the continuous monitoring is possible. These are all possible because of the benefit of applications of 5G. So when we look at the 5G platform for intelligent systems, 5G is genuinely revolutionary, not just an incremental from 4G. This is the conceptual heart of the talk. 5G redefines the network as a programmable, artificial intelligence managed platform rather than a simple radio pipe. For the first time, the network is designed for machines as primary users, robots, sensors, drones, and vehicles vastly outnumber the humans. It scales to 1 million devices per square kilometer, enabling planetary sensor network. And it becomes the foundational infrastructure for smart societies, grids, transport, health, agriculture. Remember the line, not just faster internet, but a platform for intelligent systems. So the machine-to-machine economy, 5G is designed for machines as primary users. In fact, in future, compared to the human communication, the machine-to-machine communication will be much more. And the smart societies, smart grids, intelligent transport, digital health, and precision agriculture, 5G is enabling infrastructure for the next industrial revolution. So let us see the 5G. What are the 5G features which is envisaged? First of all, it will be artificial intelligence native era. The crucial distinction of 5G. In 5G, artificial intelligence is only applied on top of the network because certain applications are utilized, 5G applications in 5G. But in 6G, it is intelligence is designed in from the ground up, from the waveform design to routing. Terahertz communication at 0.1 to 10 terahertz targets data rates above 1 terabit per second, but it demands entirely new antenna setup and materials and channel models. Integrated sensing and communication lets base station transmit data and sense environment, localization, gesture recognition, 3D mapping, and holographic communication, real-time volumetric telepresence needs exactly that combination of terabits per second rates and sub-millisecond latency. 6G is where communication, computing, and sensing fully merge. Let us see the expected features of 6G. Here, the latency is almost zero, that is less than 0.1 millisecond. And the peak data rate 1 Tbps, real-time mirrored virtual world, and it will be an autonomous network. The present network, that is the physical maintenance, is very well required. Here the self-healing technology, SON, it will detect the errors which is happening and it will correct it, and zero touch management. In fact, different kinds of technologies are integrated. Here, the aerial, the terrestrial, as well as that satellite network, these are all integrated together. And these are the expected features of 6G. In fact, then there is no latency. So anything can be done on real time. And when all these networks, satellite, aerial, and terrestrial, are stitched into one fabric, the timeline to set expectations, the 6G is expected to be standardized by 3GPP, that is the standardization agency. It is by around 2022. And to start 2028, and to start commercial deployment from 2030. So today's student will be the engineers who actually build it. So let us see the potential application, the envisaged applications of 6G. The potential applications of 6G are like science fiction, but each follows from those features. An immersive metaverse, photorealistic shared 3D worlds for millions at once, smart healthcare with nanoscale robotic surgery and continuous in-body biosensors, advanced robotics over the tactile internet with human equivalent precision across continents, real-time digital environments, living digital twins of cities and factories for predictive governance, intelligent transportation, vehicle platooning and drone highways, and holographic telepresence replacing video call entirely. The connecting thread is a sustained terabit rates at sub-millisecond latency. In fact, because these are technology which is said to be introduced, and almost all the major countries, because they are all participating in this. Recently, you might have seen that SpaceX by Elon Musk. In fact, his next vision is that the nowadays the AI capabilities and in the meet future computing demand thinking beyond Earth. He is thinking beyond Earth. That is because his data centers, he is planning to introduce data centers in Moon and Mars. The concept involved setting up a facility on the lunar surface that would build satellites tailored to support next level AI systems. 100 terawatt per year is possible from a lunar base producing solar powered AI satellites locally and accelerating them to escape velocity with a mass driver. Why the moon over? Why is thinking about moon over Earth? In orbit, data centers can cost of the heat directly into the freezing vacuum of space without relying on air cooling technologies are not required. And again, the sun provides continuous supply of energy. So energy is so expensive. Once you build a space center, your biggest operating expenditure will be minimum. So in fact, Elon Musk recently in the vision list, he has already started introducing data centers in Moon and then subsequently in Mars. And you might have seen that the SpaceX, the primary issue which has happened, and it has made him that the first trillionaire in the world, the richest person in the world, Elon Musk. He's having ideas which normally a person normally doesn't think. And as far as possible, we could see that he is implementing it also. So in fact, Internet of Things, this is the future because humans may talk much lesser than machines. 75 billion plus machines are expected. IoT devices are expected by 2030. More than 1 million devices by 5G itself it is introduced, and much more equipments can communicate or Internet of Things can communicate. And the battery life, that is a major issue now. The battery life has to be enhanced to more than 10 years in this technology. The Internet of Things is the demand driver behind all of this connectivity. The numbers of over 75 billion connected devices expected by 2030. Density is up to 1 million per square kilometer, more than million. And the battery life targets of 10 years for sensors. For domains to know, smart homes, because all our homes can be made smart. In fact, we need not buy the items thinking by ourselves. We can just program everything. Your fridge, when it reaches an optimum level, the required items will be automatically ordered and the items will come to your home. Sensors managing the energy, the traffic and air quality. Industrial Internet of Things, the real-time predictive maintenance. In fact, that is one of the areas where, because in the factories will have usage of minimum manpower and the quality control. And it continuously it's monitoring the quality by which A separate quality control department is not required. So that the quality of the product also will be the best. And in the factory floor itself, the quality can be monitored and it can be maintained. The healthcare, wearable and implantable biosensors, streaming vitals with artificial intelligence catching anomalies early, and the connecting networks themselves. The LoRaWAN, narrowband diode, Sigfox, low power links, reaching remote sensors. IoT SWAT turns connectivity into intelligence. How the artificial intelligence is introduced in the telecom. In fact, dynamic spectrum allocation. Spectrum is very expensive, and the telecom service providers want to utilize the spectrum with maximum efficiency. So dynamic spectrum allocation is possible, and the load can be balanced and with the interference mitigation. And the predictive maintenance, in fact, the equipment maintenance means the breakdown can be predicted well in advance and the maintenance can be done before the actual breakdown happens. And earlier, when the circuit switch systems were used, you might have seen that when you are making a call from Kerala to maybe Bombay or Delhi, because of the high traffic, a lot of congestion was happening. Because this also can be managed very well. In fact, in the IP network, this is already taken care, but the AI routes data through least congested path in real time, by which there won't be any traffic congestion and all the routes are well occupied. And fraud detection, because in the new era, there are a lot of frauds are happening, how the anomalies can be detected and unusual SIM activity within the milliseconds itself, it can be detected. And the quality of service, artificially personalizes bandwidth and latency for each user's application. Artificial intelligence is becoming the brain of the telecom network. In fact, whatever I explain, once again, I'll repeat. 5 places it's already at work. Network optimization, dynamic spectrum allocation, and interference management. Predictive maintenance, the forecasting equipment failure before an outage itself, and the traffic management, routing data through the least congested path in real time. Fraud detection, flagging unusual SIM activity in within milliseconds so that fraud can be detected and such type of customers can be deactivated. And the quality of service, personalizing bandwidth and latency per application. But this heading is AI RAN, AI native radio access, which will define 6G, where every radio decision is made by neural networks. In fact, the satellite communication, because you might have seen that in certain areas, like even when you are traveling in the sea, some areas the coverage is not at all there, even though we are using satellite communication for this purpose. And some of the remotest parts, there the LEO satellites, low orbit satellites are already done. That's in fact SpaceX in the lead role, which they are doing throughout the world. Satellite communication is having a big role and it's new part of the cellular roadmap. The key is orbit. Thinking less, geo satellites, it's around 36,000 kilometers. In fact, it is used for broadcast and weather forecast. And MEO satellites, it's a GPS and navigation purpose it is being used. In fact, the LEO, a few hundred to 2,000 kilometers, in that range only, these LEO satellites are there. This is the disruptor, giving sub 30 millisecond broadband, but Starlink, OneWeb, and Kuiper deliver hundreds of Mbps anywhere on Earth. Oceans, poles, remote villages, satellites. This satellite deploys in minutes after disasters when terrestrial networks are destroyed. Because the communication is normally, if it is disrupted, whenever there is a natural calamity is there, we are not able to communicate. The satellite networks can do that. And 3GPP is non-terrestrial network standards now fold satellite directly into 5G and 6G, one seamless radio access network from ground to orbit. fact, cloud and edge computing in telecom. Cloud and edge computing form a continuum in modern telecom. It is not cloud or edge, it is a hierarchy matched to latency needs. At the top, centralized cloud, long term storage, artificial training, global orchestration, regional edge handles caching and analytics at 5 to 10 milliseconds. The far edge, right at the base stations, serves the under 1 millisecond cases. Autonomous vehicles, augmented reality, robotics, and on-device interference handles things like Face ID locally. The benefits: scalable capacity, zero trust security, sub-millisecond edge latency, and greener efficiency. Match the workload to the right there. That is the design skill. So software-defined networking, that is the next area. In fact, earlier the networking is done manually. Now because this by a software, we can define it. It separates the control panel from the data plane and centralize the control programs forwarding rules across all network devices. And it enables the dynamic traffic steering, policy enforcement, and real-time network reconfiguration. In fact, the network function virtualization, that it replaces the dedicated hardware appliances, firewalls and routers with a software running on commodity servers. This network function virtualization is possible. Network functions become virtual network functions deployable anywhere in the cloud. What is the benefit? It reduces the capital expenditure as well as the operation expenditure. It's a rapid service installation in minutes, not months. Earlier, because the physical installation was taking months, but now in a few days it can be done. In fact, this SDN, and this is in a big way, it is introduced in our telecom networks. They're abstract. So let me make them concrete. Software-defined separates the control plane from the data plane. SDN and NFP are the foundation of the cloud-native 5G core. They are what make slicing and Open RAN possible. So you might have seen that because there are a lot of problems happen in the network. But cyber security is very much essential and it has to develop. Whenever we are introducing a new technology, there are various loopholes also found by human being. And it is in fact, the good benefits of that technology is also misused by some people. So as networks carry everything, security becomes quite essential. Now the threat landscapes first. SIM swapping is whenever it's happening because people are misusing it. The 5G response, end-to-end encryption is introduced, but even then, there are security issues are there. So the continuous monitoring of the network and the cyber security platforms are also to be introduced. 5G gives a mutual authentication between device and network with certificates replacing shared secrets and a governance framework. GSMA NESA 3GPP SA3 mandates security by design. The principle to take away 5G and 6G security in architect from the start itself. It's not patched on later. So the industry application on the smart manufacturing, when you look at it, the fourth industrial revolution has happened along with 4G and 5G. So probably the biggest commercial story for 5G. What are the 6 pillars on the smart factory floor? Robotics and cobots sharing space with the human. In fact, these are all controlled wirelessly, not physical wiring is not there. Industrial IoT, thousands of sensors feeding digital twins. Sensors are implemented at various locations. They measure the values and continuously monitoring. And real-time monitoring happening with the sub-millisecond and almost less than 0.1 millisecond when this 6G is going to be introduced. and the CNC and welding and all that, because it's all here without much difficulty it can be done. And the predictive maintenance, because I already explained that one. AI predicting bearing failure weeks ahead, saving millions in downtime. Otherwise, because the network is down, then only the maintenance is happening. Private 5G networks slicing the factory for different needs, and digital twin integration, a live replica of every machine for simulation driven optimization. This is where EC meets manufacturing and where a lot of job opportunities are there. So the different technology, because the green revolution, along with that one, because our communication technologies are also to be energy efficient, it has to be made. ICC sector accounts for almost 3% of global CO2 emissions, and 5G is 90% more energy efficient per bit than 4G. In fact, 6G target net zero operations. We cannot ignore the sustainability. The ICT sectors is around 3% of global carbon dioxide emissions, comparable to aviation. The good news, 5G is about 90% more energy efficient than 4G. How we get greener? Then massive MIMO antenna shutdown and artificial intelligence driven cell sleeping base stations powered by up to 70%. Green data centers moves to liquid cooling. The liquid cooling technology will be used, and renewable targeting power usage effectiveness below 1.1. Solar and wind-based stations eliminate diesel in rural areas. In rural BTS sites, especially because the tower were installed, the power continues 24-hour power requirement is there. In that areas nowadays, so most of the companies they started using the solar power or the wind power. The Ericsson, Nokia, and Vodafone, they are all committed to introduce solar or renewable sources of energy by 2030. 6G is expected to bake energy KPIs into the protocol itself. Net zero is becoming a design constraint, not an afterthought. So the research areas, in fact, 6G research is happening. And here, the terahertz communication, that is a challenge. Channel modeling, the material science for terahertz antennas. In fact, the material which is required for antennas, that is also to be developed. The beam management and rain fade mitigation. In these particular frequencies, how the fading can be avoided. These are the certain challenges of 6G radio design. And here the AI native autonomous network. In fact, artificial intelligence is already introduced in the design itself. And it is the large language models for network intent translation. Quantum communication is introduced. In fact, bit-to-bit instead of bit-to-bit for packet communication, here the quantum key distribution provides the information theoretically secure channels. Quantum repeaters extend, reach beyond 100 kilometers. Post-quantum cryptography secure classical networks. And here the network will be green and sustainable. Energy harvesting from ambient, radio or solar, near zero power communication for backscatter carbon aware routing that minimizes network emissions per bit transmitted. So in fact, AI native autonomous network, it reinforcement learning for self-organizing network, federated learning across base stations, and green sustainable telecom, energy harvesting and carbon aware routing. Also, active integrated sensing, reconfigurable, intelligent surface and semantic communication. So what are the major career opportunities in the next generation communication? In fact, in the fifth generation and sixth generation, in India itself, because it has offered several job opportunities for electronics and communication engineers. The design, deploy and optimize NR radio networks, expertise in wave propagation, massive MIMO, beamforming and 3GPP standards. And again, in Internet of Things solutions architect, because when you go to some of the startup companies, we can see that in Kerala also, because there lot of new IoT technologies are developed by this startup. Design end-to-end IoT system from sensor hardware to cloud analytics and skills in embedded system, LP-WAN, edge computing, and data pipelines. Artificial intelligence and telecom analytics engineer, machine learning to network planning, traffic prediction, anomaly detection, and energy optimization. And this for as a network analytics engineer, good scope is there. And cyber security. In fact, almost all the banks and the financial institutions, they are doing a lot of investment in cyber security, because even a small problem can create their confidence level reduction. 5G, 6G core and RAN infrastructure against emerging threats. Expertise in 3GPP and security specs. Zero trust architecture and so on. Satellite communication engineering. Again, design LEO constellation link budgets. In fact, Elon Musk's new companies will offer several opportunities for the people. Ground station system and inter satellite links. Indian integration with 5G NR and 3GPP release 17 plus. So these are various 3GPP releases. And build and deploy virtualized network functions and 5G core software development. And all this, in fact, 5G, 6G, and the telecom technologies are giving a lot of opportunities for the electronics and communication engineers. So what are the key takeaways? In fact, the analog to intelligent network from first generation analog voice to 6G, AI native systems, each generation delivering an order of magnitude leap in capability. 5G and 6G are industrial catalysts already transforming healthcare, manufacturing, and transport sectors, soon enabling holographic and tactile application. Third, the future is defined by convergence, artificial intelligence, IoT, cloud, and edge together, not the radio layer alone. And fourth, next generation network must be intelligent, secure, and sustainable simultaneously, a genuine multi-objective engineering challenge. That challenges is yours, you can take on. All the telecom engineers can take on these challenges. So I'm stopping this PowerPoint, so can have an interactive session. So any clarifications?
Thank you, sir. The platform is open for the participants. Participants can share their questions or suggestions in the chat box, or you can unmute yourself and ask the questions directly. We have few more minutes to clarify your doubt. So participants can share your questions or clarifications through the chat box. Sir, we have one question in our chat box. While 5G is more energy efficient per bit than 4G, the number of connected devices is rapidly increasing. Can green communication technologies offset this growth in demand and still help the telecom sector achieve net zero emissions?
Yeah, in fact, all the telecom service providers are trying to reduce the zero emission. In Kerala, when you look at it, because the rural areas, especially in the BTS, we provide for generating continuous electricity, generators are also provided. In fact, the carbon emission is happening. So, in the recent past, to the maximum extent, it is replaced by so in fact, solar panels in most of the places wherever, because continuous means light is available, and in some locations, wind energy is also used in, especially in Tamil Nadu and in the rural means in the coastal belts they have introduced. I could see in some of the other countries like Norway, Sweden, and all that. They are totally dependent on because the renewable energy methods because they are not using the generators where because the carbon emission is there. And when the technology because is getting upgraded 4G to 5G and 5G to 6G, the number of equipments or the devices communicating is can also be increased because the technology will be developed like that. In fact, in 6G, what they are telling that the drones, for example, in the Iran-US war, you might have seen that mostly because unmanned drones are being deployed. In fact, this also can be monitored in this technology. Because anyway, under this development, these are all happening. Because it will be more energy efficient and it will be more of green energy rather than the carbon emission will be reduced to the minimum extent. And the power requirement also, they are planning to reduce to the minimum extent so that because there won't be any carbon emission.
Thank you, sir. Thank you very much for your generous response. On behalf of the Department of Electronics and Communication Engineering of Jyoti Engineering College and on behalf of all our participants, I extend our heartfelt gratitude to Dr. P.T. Matthews, sir, for this truly enriching session. Thank you, sir, for a comprehensive, policy-rich and wonderfully grounded session on the future communication of networks. Your years of experience in the Department of Telecommunications gave your presentation an authoritative and real-world perspective that no textbook could replicate. The regulatory, infrastructural, and deployment dimensions you brought into the 5G, 6G discussion give participants a truly complete picture. We are proud to have you as an adjunct professor at Jyoti Engineering College. We wish, sir, the very best in all your future endeavors, and we hope to have the privilege of your presence and guidance again. Thank you very much, sir. Thank you.
Thank you.
Okay, we are going for a short break. Our next session will begin at 1 p.m. today. Be ready and logged before 1 p.m., preferably at 12:50. We are privileged to have Mr. P. Balakrishnan, Vice President and Business Head Communications, Verticals, TCS, who will be presenting on technology trends in communication industry. I'm sure it will be another enriching session. Thank you all. Thank you.